Welcome everyone to another episode of the Biohacking Beauty podcast. My name is Amitay Eshel, co-founder and CEO of Young Goose, the world's first biohacking skincare company. Today, I'm here with Dr. Paniz Jasbi, a real powerhouse in the worlds of biomedical science. As an accomplished scientist, Dr. Jasbi brings with him a deep passion for translating the intricate scientific findings in metabolomics testing into tangible, practical applications. Not only is he the founder of and chief scientific officer of Theriome, a company breaking barriers in the realm of metabolomics and personalized medicine, but he also dedicates time to patient education and advocacy. Beyond his innovative contributions, Dr. Jasbi lends his expertise as an associate editor for Frontiers in Molecular Biosciences and a guest editor at Biomedicines, which is like super impressive. I mean, it's one of the most prestigious magazines there are. Now, some key takeaways from our conversation today. We'll delve deep into metabolomics, we'll understand the revolution that is personalized medicine, and we'll explore how Dr. Jasbi's groundbreaking work at Theriome and the Aristotle metabolomics test is paving the way for the future of health. This is not lip service. I am so excited about this episode. As we navigate our discussion, we'll unearth the intricate connections between our unique metabolomic blueprints, health, and ultimately the vitality of our skin. Before we dive into this enlightening conversation, I want to spotlight a review from one of our valued Biohacking Beauty listeners. She's saying, I've been an ardent follower of this podcast, and every episode leaves me with newfound knowledge and insights. It's my weekly dose of beauty wisdom. Thank you, Elle. I highly appreciate it. If you haven't done so already, we would be so grateful if you could spare a moment to leave a rating and review on Apple Podcasts. Even a single word can make a world of difference. Your feedback is the driving force behind the growth of this podcast, helping us enlighten and empower more individuals. Okay, without further delay, let's dive into our rich conversation with Dr. Paniz Jasbi. All right, so welcome everyone to another episode of the Biohacking Beauty podcast. Paniz, welcome to the podcast, finally.
Thank you so much, Amitay. Yes, after a few rescheduling attempts, we finally had the chance to connect, and it's my privilege to be here.
Yeah, I told you off air that it is my privilege, since I believe this is a big part of the future of health. So to be able to talk about it and to hopefully introduce it, hopefully not for the first time, but introduce it to people who are listening is I really consider it as a mission and a privilege. So first of all, great to have you on, and it's great that people like you have taken up the mantle and are doing what you're doing.
Appreciate that, Amitay. So, I'll let you guide the discussion, and I hope my answers can be insightful and helpful to your listeners.
I'm sure they will. Yeah. So, I mean, let's kick it off. Just maybe giving a broad understanding. Can you start by maybe briefly explaining what metabolomics testing is for our listeners, and who should be taking them? Let's start with like a broad understanding of what it means.
Sure. Yeah. I'll I guess introduce Theriome and the Aristotle test and metabolomics all together, if that's okay with you. Mm-hmm. So I myself, my name is Dr. Paniz Jasbi. I'm the Chief Science Officer of Theriome, and Theriome is really the representation of cutting-edge convergence of technology and health sciences, aiming to offer personalized insights into an individual's health and well-being. Now, at the heart of Theriome's offerings is the Aristotle test, which is a specialized diagnostic tool designed to evaluate a person's unique metabolic profile. Now, that leads us to metabolomics, which is the science underpinning the Aristotle test. It's the comprehensive analysis of metabolites within an organism. And so metabolites are small molecules, the intermediates and the products of metabolism. And they're essentially the end products of our body's various processes and provide a real-time snapshot of our physiology. So by examining the abundance, presence or absence of these metabolites, scientists can glean insights into an individual's health status, their nutritional habits, potential imbalances, and much, much more. So the significance of metabolomics cannot be understated. Unlike genomics, which studies our genes and offers a blueprint of potential health trajectories, metabolomics provides a real-time overview of what's happening inside our bodies right now. So it's akin to reading a live report rather than a static blueprint. And this dynamic approach is what makes the Aristotle test and metabolomics so revolutionary. By analyzing these metabolic markers, the Aristotle test can, as we've experienced in our testing and practices, they offer actionable insights tailored to an individual's current state of health, allowing for more precise interventions, dietary recommendations, and health strategies. And in essence, the Aristotle test, through the lens of metabolomics, offers a pioneering window into our health, allowing us to understand and optimize our well-being like never before.
Beautiful. Yeah, I mean, and you raised a fantastic point, which normally people are very excited about genomic testing, but really genomic testing is I don't know if to call it like wishful thinking, but really what it is, it's a hypothesis of what may happen to you during your lifetime. Obviously, it is. I mean, it's taking aside in the age-old discussion of like nature versus nurture. Whereas I believe like metabolomics, what's beautiful about it is it's just reality. It's just what's going on right now. So that is very exciting. I wonder, how did you get involved in metabolomics and then Theriome to begin with? Like what drew you there? A little bit of the story there.
Sure, absolutely. So I got involved in metabolomics during my master's program, actually. I was studying various lipid markers related to digestion in my master's program. And I was introduced to an amazing professor who was new at Arizona State University, Professor Highway Gu. And Dr. Gu did metabolomics, and a part of metabolomics is another science known as lipidomics, which is instead of looking at the aqueous metabolites, you can look at lipids, right? And so it really merged well with what I was trying to do, was essentially analyze levels of certain medium and long chain fatty acids in these mice colonies I had. And instead of doing every analyte one by one, or every class of ceramides or something one by one using benchtop assays, Howie was introduced to me, and we began a relationship of collaboration whereby he had a lipidomics panel. So using liquid chromatography tandem mass spectrometry, which is one of the, I would say, three main platforms used in metabolomics, he was able to really look at my samples and classify thousands of lipids at the same time. Wow. And so this high throughput technology was really attractive to me. And then later on, I got involved with lipidomics and then metabolomics, and then I got into biomedical diagnostics. And since then, I've had, I think, I would say, a relatively successful career focusing on metabolomics and specifically method development. So looking at specific classes of target analytes and coming up with a exact assay for them, testing it, optimizing it, and then applying it, also not just the method development side, but the application side to various diseases, trying to come up with new biomedical diagnostics, either less invasive, more accurate, less costly, less time intensive, labor intensive, etc.
Interesting. So from there until Theriome, what's the route to Theriome?
Yeah, you asked that. I forgot to answer that. So what happened was during my doctoral training. Now I'd met Dr. Gu in my master's, and I had become his PhD student. I became exposed to other people at the university that were practicing systems biology. And so metabolomics is a part of that community. And so you have genomics, transcriptomics, people doing RNA-seq on various samples. You have proteomics, of course, which is maybe one of the more well-known omics sciences. And my co-founder, Dr. Alex Moore, who's a microbiome specialist, we became very close. And through the course of our studies and our publications and our patents, we quickly realized that what we can do at the university level, at the organizational research institute level, and what is practiced at the clinic and in hospital systems, there's a great disparity. There is an immense chasm between our real potential to help people and what is actually being implemented to help people. And this is really the age-old problem of, the bottleneck in translational science, or the people who are sort of in the middle and are facilitating that bench to bedside translation. And for a myriad of reasons, there has been a bottleneck in this, whether it's inconvenient testing methods, whether it's inoperable machine parameters that aren't translated well from study to study, whether it's the actual culture of science, which in many ways de-incentivizes this translational science. Translational scientists do not become sort of the head academicians, as well as myriad of factors, including the inherent difficulty and complexity of systems biology data and translating that in a cogent, actionable manner to customers or patients. All of this had really become, overwhelming, and we pointed out to these in our respective dissertations, and we said, we have so much we can do, but as soon as we publish a paper on how to change the microbiome for increased, protein absorption, or how to utilize metabolomics for early breast cancer detection, or we patent something on a new non-invasive way to diagnose valley fever here in Phoenix, Arizona, where it's really prevalent, and then that's it. It just ends right there. The paper is accepted. It goes to this very prestigious journal. We all pat ourselves on the back, and it's on.
You get brownie points and you move on.
That's it. You add it to your CV and you keep going, and that is sort of, for the most part, the academician's path. And although some academics have been incredibly successful in bringing together, entities along with the university, and they're sort of at the intersection of academia and industry, that is the overwhelming minority. So the vast majority of academicians, we're research scientists, we're very much focused on doing this one thing over and over again with very little direct benefit or translation. And so we can, we had this angst, Alex and I, and after our doctoral training, as we both entered our postdoctoral fellowships, we made it our mission to intentionally and aggressively aim to translate these findings, these inferences, these interventions to the direct user. And so we created Theriome as an entity to do so.
Yeah, and that's so. I mean, that's something I never talk about, but it's super interesting. Honestly, a lot of what we are doing at Young Goose, as far as like creating formulations, in air quotes, like that were never seen before, it's really the reason they were never seen before is they're buried in some study in a university. Like I'm not gonna throw a university under the bus, but it's a European university published a study on how a specific ROS scavenger can help red light therapy. That was like I think 2010, and they just everyone's not, and no one that dealt with it is even there anymore. And that was on the table. I was fascinated with it. We contacted the university. They're like, yeah, we can give you the study. You can do whatever you want with it. We're so over it. We're not there anymore.
Yeah.
No one cares about it. Go ahead. And it's one of our most beloved products. So that's
sure.
I can 100% relate. So before we got on air, you told me how funny it is that normally you talk about early breast cancer detection and Alzheimer's, and now we're going to talk about skin health. So within those diagnostics, what can the test that you guys developed, what can we glean into? What results can we get? What knowledge can we get from those tests?
Yeah, that's a great point, Amitay. So we have. Our report is designed, first of all, what we do is we monitor 126 aqueous metabolites from our customer's dry blood spot sample. And so it's a dry blood spot kit that they receive at home. It's a finger prick. They put it on the two areas that are demarcated for the sample to be placed, and they ship it back to our lab for central processing. And at that point, we will, precipitate the proteins, extract the aqueous layer of metabolites, and analyze it with gas chromatography mass spectrometry. And this, again, allows us to, instead of doing every analyte, every metabolite using a sort of kit assay at the benchtop one by one by one, and utilizing a vast volume of blood to do so, we can do so with, we can monitor 126 metabolites using just 20 microliters of blood. And there's various reasons for that, and we can get into the specific physics and thermodynamics of this machine that allows for that. But what do we do? What do we report on? So our customers get, first of all, levels of every single one of those 126 metabolites, including a general description of the metabolite. This may include some, fun facts even about the metabolite, like shikimic acid was discovered by a Japanese scientist in the 1940s studying mushrooms. And then given the level of the metabolite and the clinically significant normative ranges, so anything below or above would be considered clinical significance, we also give a description of the implications of low levels and high levels for each single metabolite. And this is all cited. So our report comes complete with, depending on the specific results, 200 to 500 citations. So it's very well curated scientifically, and it's designed to be transparent. In fact, invite our customers to take that DOI, put it in their browser, and learn about that metabolite through the lens of the study that the data was mined from. And in addition to that, so 126 metabolites analyzed discretely, again, is sometimes of an information overload. So what we've done is we've created these validated metabolite sets. So there are a specific combination of these metabolites that are algorithmically mined and validated, meaning that we test the data for a statistical property known as overfitting. And overfitting means that the data is too closely fit to, so the trend line is too closely fit to the training set, which is our mined database. And if it's too closely fit, then that data won't necessarily generalize well to test cases or our customers, new cases. So without having that external validity, modeling in systems biology is moot, because it is really just, you could be modeling sample error in your training set. But we have validated all these data sets, and they include different numbers and combinations of metabolites. So for instance, our liver health has upwards of 50 metabolites in that set of the wider 126 metabolite panel. And we've combined these to really speak to the levels of the health systems that metabolites and metabolomics. You mentioned the nature versus nurture debate. Metabolomics sits at the direct intersection of nature and nurture, right? It is at that nexus point downstream of the genome.
It doesn't care. It doesn't care.
Right. It is agnostic to potential probabilities or what's going. It's that intersection, right? It's upstream of the environment and downstream of the genome. It is the ideal level. It's a very attractive level of systems biology to test if we're looking for the most dynamic and sensitive picture of a person's health. And so we've combined them into 12 health domains. And to your listeners, there's a few that might be incredibly interesting. For instance, the integumentary health index, which is skin, hair, nail, and teeth health. We also have the nutritional index, which looks at the nutrition of our customers, their dietary patterns, et cetera, and really analyzes them in a global network. And then also, of course, the inflammatory index. So inflammation is very important in the context of health and beauty. And so we have an inflammatory index that looks at metabolite markers related to that. In addition to that, we have our aging index. We have mitochondrial health, cardiovascular health, reproductive health, liver and gut health, a neurocognitive index, as well as an environmental toxin exposure index and a mutational load. And so these are reported on a normalized score between 1 to 10, from poor to normative to optimized. And then we use our machine learning algorithms and AI to essentially generate a list of recommendations tailored and very much bespoke to that customer's global metabolic profile. And then those recommendations, of course, are gleaned from not just AI, but what's known as a digital twinning platform. So we take your global 126 metabolic expression levels, and we also combine that with what we call our Omni survey, which is this 33 question survey that touches on various biopsychosocial factors, which help us contextualize your metabolite results and give even deeper, more personalized insights. And so with this combination, we actually create, let's say we have a sample from Amitay. We create a digital Amitay, and it's not necessarily like a little version of you on my screen. It's actually just code, and it's just data points of Amitay. It's a mathematical abstraction of your metabolism and your relevant biopsychosocial factors. And then on that Amitay, we have curated, upwards of 300, almost 400, last time I checked, like 474 or 374 interventions. And those interventions can be something like NAD boosters or resveratrol or senolytics, right? And specific dosages, frequencies, duration of what was reported in that study, and the effect sizes and significances. And we can model the hypothesized effects of every single interaction. We model it 1,000 times. We run 1,000 iterations on digital Amitay to give him a set of personalized recommendations that are in silico, designed to give you the greatest increase in poor scores or push normative scores into the optimized range, et cetera, across these 12 health domains. And this is really important because instead of you going out and experimenting, thousands of times on every different product and taking the time and money and also the opportunity cost of other interventions you could have been observing in that time, we are able to experiment on you in silico and let you benefit from and leverage the power of that in simulation experimentation and give you the most personalized and best health recommendations to maximize your return on investment. And then also we have a database of 344 blood disease signatures reported and validated in human blood. So those range everywhere from schizophrenia, acute seizures, histidynemia, enzyme deficiencies, Alzheimer's, cancers of various kinds and stages. And we present a risk score given your current metabolic profile match to that disease profile as it's been reported in the literature.
Super interesting. I mean, first of all, I don't think we talked to anyone in this podcast about big data, right? That's unique. I mean, I think it's, again, as I said in the beginning, that's a peek into the future of health in general. And I think it is as groundbreaking in what you guys are doing in Theriome, aside from the identifying the metabolomics part, like the idea that you can now apply big data to take my digital avatar and crack the code, no pun intended, on what optimal health would look like for me. Basically, living in air quotes, like living 1,000 lives for me, and then giving me the best version of myself. I think this is obviously, that's the difference between having the ability to drive people around. I mean, before Uber, I think I gave this example before, but Craigslist, people could ask for rides on Craigslist probably 10 years before Uber came along, or Lyft, or whoever was first. But what Uber did is improve the interface. And I think it's as valuable as the ability to drive people around.
Absolutely.
So this is beautiful what you guys are doing. You mentioned how do you call it? Integumentary?
Yeah, the integumentary health score. Yeah.
Integumentary health domain in your testing. Can you dive deeper into what that entails? What does it mean exactly, or what does good skin, hair, nails, and teeth health look like in testing?
Absolutely. So, we can get a little bit into like personalized care and, crafting sort of personalized beauty through metabolic insights. So Amitay, as I'm somewhat familiar with your products, and they seem incredibly bespoke, tailored, and very much advanced in utilizing the most recent, up-to-date, curated, and impactful research into your formulations. And that's really great because in an age where the beauty industry is overflowing with these one-size-fits-all solutions, I think products like Young Goose or the Aristotle test from Theriome, they really stand out as a beacon of personalization, and they reshape how we perceive and address beauty. So by delving into the intricate web of metabolomics, our test allows us to unravel the complex relationships between our internal health and our external appearance. So we can take a closer look into, for instance, like how this is done and how a test like the Aristotle could lead to insights that would, hopefully revolutionize beauty regimens that people are observing. So we can go beyond generic solutions. So the beauty industry, as I mentioned, has traditionally been driven by trends. So one season it's all about hyaluronic acid, the next it's retinol. And while these ingredients have their merits, they might not address the unique needs of every individual. So the Aristotle test, through its metabolic analysis, tailors recommendations specific to one's profile, ensuring that their skincare regimen is not just trendy, but truly beneficial. And we can come, for instance, with customized nutritional guidance. So beauty, as I'm sure you know, isn't just skin deep, as they say. It's intrinsically tied to our nutrition. And the Aristotle test can detect deficiencies, imbalances in our customer's diet. For instance, if someone has low ferulic acid levels, they might benefit from incorporating more plant-based foods, which can enhance skin's antioxidant defenses, protecting it from premature aging due to various environmental stressors. There's also a holistic approach that we can offer to inflammation. So redness, puffiness, breakouts, they often have their roots in internal inflammation. And the Aristotle test can highlight inflammatory markers, offering insights to potential internal triggers. And by addressing these triggers, one can not only alleviate the current skin concerns, but also prevent the future ones. And we can tailor supplement recommendations, as I mentioned, based on the metabolic profile. So our customers can receive guidance on specific supplements that can address their unique deficiencies or imbalances. So instead of randomly picking up biotin or collagen supplements, our customers can make informed choices, ensuring that every pill or powder genuinely serves their beauty goals. And so we can also offer some lifestyle adjustments, right? That the test can shed light on how lifestyle factors are impacting one's appearance. For instance, a disrupted carbohydrate metabolism might suggest the need for dietary adjustments or even stress management, given the intricate relationships between stress, insulin resistance, and skin health. And ultimately, we're empowering informed choices by our customers. So equipped with these detailed insights from the Aristotle test, our individuals, our customers, can have more productive conversations with their dermatologists, their nutritionists, their estheticians, and they can offer treatments or diets or regimens that resonate with their metabolic profile, ensuring better health outcomes. And this is really the evolving world of beauty. So as one's metabolic profile can change over time due to factors like age, diet, or even seasons, periodic Aristotle testing can allow individuals to continually refine and evolve their beauty routine. So it's a very dynamic approach, ensuring that one's beauty regime remains, as fluid and adaptable as possible. So in essence, we have this integumentary health score, and it is comprised of 8 different metabolites that are given 7 different algorithmic weights based on our training data. 2 of the metabolites, which are related, are given the same weights. And then there, of course, there's an error term that is sort of coming in from your biopsychosocial factors that informs this machine learning algorithm. So the metabolites involved in integumentary health analysis are taurine. It's the first one, and I'll go in order of importance. So this amino acid is involved in various physiological processes, including hydration and electrolyte balance in the skin. So it's very important to monitor. We also have palmitic acid. This is a fatty acid, and it's a major component of sebum, or the oily substance, of course, as you know, that your skin sebaceous glands secrete to moisturize your skin and hair. And then, as I mentioned, 2 metabolites have the same algorithmic weight, and those are linoleic acid and alpha-linolenic acid. And these are essential fatty acids that are important for maintaining skin barrier and preventing dry skin. We also have ethanolamine, and this compound is a part of phospholipids and cell membranes and plays an integral role in skin barrier function. One metabolite that's very interesting is caffeine. So topically, caffeine, as you know, is often used in skincare for its antioxidant and vasoconstrictive properties. However, its impact on systemic health is really unclear, and we are still trying to tease apart those relationships. Another 2 sets of metabolites are adenine and adenosine, and these are purine metabolites. They're involved in cellular energy metabolism, and they do indirectly affect skin health by influencing cell renewal and various repair processes. And then, of course, there's glycerol. So it's a humectant that can help maintain skin moisture, and it's something that we analyze as part of our integumentary health domain. So as you can see, it's a very comprehensive and inclusive approach to monitoring it. And in essence, the Aristotle test and our integumentary health, it really can, we believe, redefine beauty care, and it steers away from generic solutions towards a really deeply personalized approach. And it acknowledges the uniqueness of every individual, ensuring that their beauty regimen is a mere reflection of their distinct metabolic profile. And it's in a world that really is seeking authenticity, this personalized approach to beauty isn't just revolutionary. We believe it's transformative.
Yeah, definitely. And I mean, I think we can glean how to, we have an idea from the metabolites that you said, how 126, if I'm not mistaken, metabolites can give us such a big kind of view into our health, because you just mentioned 2 energy, or even 3, because taurine is also there, but let's say 2 metabolites that are really significant markers that I would assume you're also looking at when you're looking at, for example, like mitochondrial health, which is adenosine and adenine, right? So these could also now be a part of a completely different set of data that is going to inform, mitochondrial health. And obviously mitochondrial health now informs us, it's a big part of skin health in general, but it is also a big part of other systems which you are looking at separately. So it's all like a symphony of different an orchestra that is playing a symphony with different tools, but they create like one music, which is you as a person, right?
Absolutely, and that's an incredibly astute observation, Amitay. Every time we have an interaction, your knowledge and depth of proficiency in science really does impress me. That what you just described is the process of multiplexing, whereby one metabolite can appear in different health systems given its relevance or importance to that construct, whether it's mitochondrial health, liver health, etc. And by uniquely orchestrating these metabolites in the right algorithms with the right training sets that our machine learning bioinformatic pipeline is built on, we are able to really see and hear and feel the symphony of a person's metabolism and speak directly to the whole as well as individual parts.
Yeah, I mean, and moving on to something that to me is as exciting as what we talked about until now, which is Environmental Toxin Exposure Score, which you mentioned. And the reason is I believe, I think it is super apparent that the same way that if you open any skin enthusiasts TikTok or Instagram, half of the posts are going to be people parroting the same message about wearing sunscreen. I believe in the very near future, the two strategies of preventing skin damage due to environmental exposure and the growing awareness of the aggressive or the aggressors that are not UV based in our environment are going to coalesce, and they're going to become like this another parroting talking point about how you should be careful about environmental toxins, heavy metals, glyphosates, etc.
Absolutely.
So, looking at this environment, so, breaking down what I said, I believe the next fad in protecting your skin is going to be in dealing with environmental toxins. Mm-hmm. Let's talk a little bit about, first of all, diagnosing that with the metabolomics test, with the Theriome test, and then what can we do what does this information allow us to do?
That's great. Yeah. So the Environmental Toxin Exposure Index is based on 14 metabolites. So it's rather one of our larger metabolite sets, and it is meant to measure metabolites related to various potential and the most really prevalent environmental toxins. First of all, we took IARC's, which is the International Agency on Research on Cancer. We took IARC's top 20 carcinogen list, and we performed sort of in silico metabolism on these to get a very clear idea of the metabolites of those. For instance, glyphosate is on that list, and looking at the metabolites affected by it during phase 1 and phase 2 metabolism. And I'll just give very brief information. Phase 1 is everything that's related to cytochrome P450 enzymes. Really, it's really a structural change, a true structural change in that carcinogen. And then phase 2 metabolism are all the conjugation reactions, whether it's methylation, phosphorylation, or the like. And so we've created a list of 14 metabolites that speak to, carcinogens, mycotoxins, various, for instance, metabolites that are related. This is some of my own research that's published in Environmental Toxicology, where we looked at the effects of TBBPA, which is a brominated bisphenol. It's a flame retardant, and it's in absolutely everything. It's in your walls. Wow. Part of it may be in your shoes, in your office buildings, in the cars you drive. And it's sprayed onto these things as a flame retardant, but we've shown that it essentially arrests mitochondrial activity, specifically in the Krebs cycle. And we did so with a very advanced technique in metabolomics known as metabolic flux analysis. So, and it's not just our research in here. I mean, we are great scholars. Our science team together has published 140 papers related to metabolism systems biology. We're a rather accomplished group of scientists, I would say humbly. But the total set comes from all the data and studies that we have mined, published, and validated in our data set. So back to the Environmental Toxin Exposure Index, there's 14 metabolites, and they are spread across 6 different algorithmic weights. And again, an error term that informs our machine learning algorithm, which is really brought in from your Omni survey responses. And so those are, again, taurine. So this amino acid is involved in various detoxification processes, including bile acid conjugation, which helps eliminate certain toxins from the body. Our second most important metabolite in this panel is glutathione. So this is an antioxidant molecule, and it plays a key role in detoxification of harmful substances in the liver, including environmental toxins. So reduced levels could suggest increased oxidative stress, potentially due to toxin exposure. In the third level, we have three sulfur-containing amino acids, cysteine, cystathionine, and methionine. And these are involved in the synthesis of glutathione and other necessary molecules for detoxification pathways. And it really highlights the fact that we're not looking at one pathway or one set of metabolites or placing undue emphasis on certain chemical classes of metabolites. These 126 metabolites were carefully chosen as part of the larger panel in order to take advantage of the inherent redundancy in biological pathways. And by doing so, we're able to monitor 68% of all known canonical human metabolic pathways. And the closest is, if you stack a few of your physician's diagnostic tests together, you approach, and I mean a few tests, 4 or 5 of them, including organic acids, complete blood count, et cetera, you get roughly 19% of, metabolic coverage. With our test, 68%. So we're very proud of that. And it's due to the fact that, like I said, we're not just looking at glutathione, but we're looking at metabolites involved in its synthesis and metabolism around it. We're looking at a much greater view of that, including these sulfur-containing amino acids. We also have, in our Environmental Toxin Exposure Index, we also have included adenine, adenosine, inosine, and guanosine. These are purine metabolites, and they play a critical role in cellular energy production and repair processes, and disruptions in their levels may indicate cellular stress or damage, again, potentially due to toxin exposure. We also have uric acid. And so elevated uric acid can indicate oxidative stress in the body, which is due to, again, environmental toxin exposures and other things. And then some of these metabolites that, have been reported in the literature, and our research team has found, again, in that publication I mentioned in Environmental Toxicology, malic acid, fumaric acid, succinic acid, and citric acid. And as I'm sure this sort of pings in your brain, Amitay, these are the components of the Krebs cycle. And they're essential for not just mitochondrial functioning, but cellular energy production. And disruption of these metabolites usually indicate mitochondrial stress, again, indicating to us some potential increased exposure to environmental toxins. And so what can we do with this information? Again, we take all of that big data, what you report to us and what we've analyzed in your dried blood spot sample, and we can create very tailored, let's say, supplements and nutraceutical plans with very specific antioxidant blends, liver detox supplements, specific amino acid complexes, or we can suggest very minute and granular dietary adjustments, whether that's diet rich in cruciferous vegetables, herbs like cilantro, or superfoods like spirulina to aid in detoxification. Also, lifestyle, right? We can guide our customers on what to do to reduce toxin exposure, personalized detox routines, or sauna sessions even. And so that is where the digital twinning platform comes in, is to say, these are the levels of these metabolites associated with toxins, and this is what has been proven by the literature and simulated on your digital twin thousands of times to give you the greatest increase in a hopefully not, but oftentimes low environmental toxin exposure index score.
Beautiful. I mean, to be frank, I think maybe the environmental toxin exposure index would be more beneficial to skin than the skin test, because what you're talking about really are the two components that I almost exclusively try to target when we are approaching a new product, which is the ability to create energy that feeds renewal and the NRF2 pathway, or its surrounding environment of obviously, we use obviously different molecules. So we use moringa extract, which is a sulfur compound, or we're using glutathione straight up. But it's super interesting that they basically coalesce. Again, we find this beautiful combination. Yeah. So let's talk a little bit about the future of metabolomics. You say that you're covering at the moment 68%. First of all, the question is that enough? Is that like the end goal and we're okay with that to continue? Or is it something that you're looking to even improve upon later on, I would say?
Yeah, so absolutely. We're always looking to improve upon it. And we're balancing analytical power with usability and price point.
Yeah.
We can do a test right now. I can give you a test. From your blood sample, we'll measure upwards of 10,000 metabolites.
Wow.
I'll give that to you right now. takes about a week to just do one sample. It's very labor intensive. It's very cost intensive. I published this with my mentor earlier in my doctoral training. It's in analytical chemistry. The method for this is called DGOT, Database Assisted Globally Optimized Targeted Mass Spec. And so it's a very labor intensive, but it gives us, like I said, upwards of 10,000 compounds. And it uses real-time database data to do this and match metabolites with their spectra. It's very advanced, but it doesn't really give us much more than we can do right now. Mm-hmm. It's not just what can we monitor, it's what do we know has health implications. And of the more than 25,000 metabolites currently indexed in the Human Metabolome database, we are, as a new science, figuring out what these do, what are normative concentrations, what are the health implications, what are their mechanistic probabilities and different pathways. And so we're figuring that out. And these 126 were chosen to give a few things. First of all, the method I just mentioned that is, much more amplitude than our current Aristotle test, that is on LCM-SMS, which has, lots of very finicky and sort of hard to do sample prep stages and reagent and solvent preparation. It's very difficult. And the database equity for it is much, much more scarce than what we have developed on GCMS, which is gas chromatography mass spectrometry. So instead of doing chromatography by liquid separation, we do it by gas separation, and instead of doing 2 rounds of mass spectral filtering, we do 1. And this gives us, first of all, much more robustness in data quality. Gas chromatography allows us to do our analysis with, like I said, 20 microliters of blood. That is more than enough, more than what our customers deposit on our dry blood spot sample. Mm-hmm. And it gives us access to a massive online database equity that allows us to just say, not only this is what we detected, but this is what it means. And that is sort of the important part of it. And so as we develop the Aristotle test, we will add more compounds to our chemical library, more compounds to our panel. And as we get more information on what those metabolites do, we will look to include them. Like I said, we're here in the translational space. So although, yes, I can report levels of up to more than 10,000 metabolites in our customer's blood using a different platform, it's very expensive, it's very time consuming, and ultimately what we give them would not necessarily be a significant advancement on our current offering. And so those 126 metabolites, monitoring 68% of the known human metabolism. And I say known because we're growing all the time, right? If you go and look at the Keck Encyclopedia of Genes and Genomes, also known as KEG, if you go look at that, the Kyoto Encyclopedia of Genes and Genomes, you will see that there are 99 index pathways, and they all have genes in them, proteins, metabolites, etc. And we can speak to the real-time functioning of 68% of that. And so we have offered something that is currently the most advanced, and we are always looking to update and maintain that next level, next generation platform technology. So while we're updating, I can't say that our analytical ability has greatly outmatched our knowledge base. So while we're able to look at a lot, we don't necessarily know what that means. But of these 126, they're very well characterized, they're very well indexed, and we can use them in very precise ways currently to speak to customers' metabolic functioning. And that's why they're included.
Incredible. So that's the question. That's the answer I was hoping to hear, and it's great. It's fantastic. A few questions again about translating it to real world, behaviors, etc. Let's say we have not we can talk about Young Goose products, but let's say we have a person that has gotten the test, they got the results, and now they're committed to change some lifestyle behaviors. They got some supplements they got recommended. Is there a way for them to now choose their skincare regimen, or even at in-office treatments according to those results?
So absolutely, we have various skincare things that we can offer to our customers. There are, and we don't sell any of these, right? We really will always remain analytically pure. We don't partner with brands to recommend them. We have recommended certain things that have been proven to be beneficial, like infrared therapy or iso-alpha amino acid therapy. So although we haven't really partnered up with a really cutting edge brand like Young Goose to do so, we definitely can, and those can lead to tailored formulations of bespoke beauty products that can lead to real time adjustments in formulations, targeted spa therapies, precision hair care, synchronizing diet diet observations with beauty habits, integrated wellness programs. We have our home metabolomics kit, and our AI-driven analysis that's powering all of that. And really, even some of the things that we recommend could be heralding in a very eco-conscious era of sustainable beauty. So we do recommend various things, and we're trying to adapt more and more. But I will say that no, we don't have specific recommendations on like you need to have a certain level of I don't know NAD in your skincare just yet. But as we add science and data and database information to our AI and our digital twinning platform, we do expect to get there. And I'm very optimistic about the future of metabolomics and beauty. The intersections, I mean, they're wild. We can talk about what I think will happen in this space, but what we're doing now is really just the first step in a 1,000-mile journey.
Yeah, I mean, to be honest now, listening to, I think maybe it's our job, maybe it's our job as a company to say, hey, there is this tool that allows people to glean into their real microscopic function of their body. Let's match products rather than waiting for Theriome, waiting for the Aristotle test to match products by us, for example. No, we should take the initiative and say, you got these results, you're lacking, again, I'm now obsessed with the toxin exposure index, but let's say you got these scores or your mitochondria isn't functioning as well. These are the products that might move the needle. And then when you test it again, hopefully you'll see a better results. Maybe it should be our job.
Maybe. And if you would like to sort of lead the vanguard in that, our health and science team is always, happy to discuss in detail how we can do that and how we can better inform. And that, that's the goal. Like I mentioned, I think the future of this space is absolutely mind-boggling, and where we'll be in 20 years. I'm so hopeful, and I think it's going to be almost sci-fi-like, given the rate at which we can develop these things.
So this is really, I mean, aside from having, I'd love for you to talk about the future of this. Aside from having the same way where you're now going to your dentist and they're asking you for whatever scans you've had before, so they can see where you were and where you're at now. Aside from me imagining, the Aristotle test being a benchmark where, you should bring that already before you're meeting your primary care physician or whatever. What else, how do you see the future?
Yeah, so the future implications are vast. I think we're going to see the dawn of Metabolomics, which is already a term being used. And so this is, the future of metabolomics and health and beauty. And so the intersection of metabolomics, health, and beauty really offers a tantalizing glimpse into the future of personalized care, where individual metabolic profiles guide the creation of bespoke beauty regimens. And so as we dive deeper into this confluence, we can foresee several groundbreaking advancements that could truly revolutionize the world of beauty. So one of them is, like I mentioned, these bespoke beauty products or tailored formulations. So imagine products formulated not based on skin type, but one's unique metabolic markers. And these products would essentially cater to the specific needs of an individual's skin, addressing imbalances at the cellular level. For instance, someone with a deficiency in certain fatty acids reflected in their metabolomic profile might receive a skincare product rich in those exact components. We can also, as I mentioned, do real-time adjustments. So with the advancement of wearable technology and at-home testing kits like ours, it's plausible that in the future, individuals can monitor their metabolic profiles in real time. So skincare devices could adjust their formulations daily based on those readings, ensuring that the skin receives precisely what it needs at any given moment. And there's also the idea of these sort of coming up to come advanced beauty treatments like targeted spa therapies. So future spa treatments could involve an initial metabolomic analysis, and based on those results, therapists could use specific oils, serums, or techniques tailored to optimize that client's metabolic health. And that would not only enhance relaxation, but also directly improve cellular health, promoting visible, beauty benefits. And there's also precision hair care that's becoming much more popular, and much like skincare, hair care treatments at salons could be driven by metabolic insights. So treatments could target specific deficiencies or imbalances to promote hair growth, volume, and shine by really addressing and offering remedies at the cellular level. And there's, of course, synchronizing, as I mentioned, the diet and beauty. So the link between nutrition and beauty will be further emphasized in the future, and nutritionists and dermatologists might collaborate to offer combined dietary and skincare routines based on metabolic readings. So if a metabolomic test indicates low levels of certain vitamins, an individual might receive both dietary recommendations and complementary skincare products together. And beyond the diet, we can, go into these, integrated wellness routines, and metabolomics can guide holistic routines encompassing sleep, exercise, stress management, all tailored to optimize metabolic health and by extension enhance beauty. There's also these smart beauty devices. So these can be really, used in tandem with home metabolomics kits. So just as we have home pregnancy or blood pressure kits today, we might soon have devices that offer a quick read on a specific smaller set of metabolic markers. And these devices could sync with other smart beauty gadgets like a skincare fridge, adjusting, again, in real time product formulations accordingly. And as entities like ourselves begin to, adopt and implement artificial intelligence, and as the field of AI progresses, it's plausible that we'll have an AI-driven platform analyzing, the metabolomic data, cross-referencing it with the most up-to-date scientific research, and just like we are, but then really using that in the context of skincare, hair care, and other beauty regimens. And as we, sort of struggle with the effects of climate change, we may have more sustainable beauty. So as personalization deepens, there will be a reduced need for mass production of generic beauty products. And those tailored products could reduce waste and ensure that individuals only purchase what they use and use what they need. And so this bespoke approach would not only be good for the skin, but potentially for the planet. And it's that marriage of metabolomics with health and beauty that really heralds a future where beauty solutions are not just skin deep, but are deeply intertwined with our internal health. And this new era, often referred to as metabo beauty, will be characterized by a high degree of personalization, ensuring, again, that each individual's unique beauty shines through, supported by the pillars of science and technology. It's really a future where beauty and well-being walk hand in hand, each enhancing each other.
Amazing. Paniz, we're in. Where do I sign? Listen, this is so interesting, and I think there are a few ways to look at this. We just did a podcast, myself and Anastasia, which is my partner, just did a podcast about vitamin A's in their different forms, and we were obviously, there is a place and time for everything. Mm-hmm. And we really skirted around the activity of cytochrome P450 because around the question of which form of vitamin A, retinol, retinoic acid, etc. Right. We want to recommend a person because this is, this and its counterparts are what break down retinoic acid. Right. So that is so interesting that we have only one form of retinol and one concentration because we're saying, hey, we cannot know how the individual metabolizes or breaks down vitamin A. So we need to create like one product that is one size fits all. Right. But with something like what you're doing, this is an incredible way to advance into individual products. Within that, I would say from the skincare side, it is almost there as far as capabilities, because right now there is a company, they're called SkinCeuticals. They're one of the kind of OG previous generations professional skincare products. Mm-hmm. And they tried, I think very wisely, to corner off parts of the market or kind of to shackle some professional facilities, medical facilities to them by creating a machine that creates a customized serum. It's not customized, but it's expensive. It costs so much money that the doctor has to use it for a very long time to justify the cost. But I think since they've shown that you can introduce something like that into a professional facility, it only needs to be made, I would say, more you know, no offense to anyone, it more reliably or more consciously in order to create a real effective skincare manufacturing machine. That's, I mean, we're in. Listen, let's do something unique.
Yeah, absolutely. I would absolutely welcome some sort of scientific engagement between our entities, and you know Micah very well. You guys are friends, and so maybe we should send out a kit to you, Amitay, and have you sort of test drive our product and really experience it for yourself, and do the AI analysis and the digital twinning and the follow up consult with one of our personalized health consultants. And the future is bright, and as long as we keep making these strides, I'm very optimistic that we will eventually reach our end goal.
Absolutely, and obviously Micah is a dear friend. We are very, very fond of you as well, and obviously we got introduced to you by another giant walking between us. He is actually a giant, Thomas Sager. So that I mean, we're on your corner too, and we'll make sure that happens. The world needs it.
Thank you so much.
Talking about that, and I'd love a test. I think obviously after this podcast, I would love it even more, but I would have loved the test before.
Sure.
Kind of wrapping it up. How would someone listening to this podcast, and I'm sure a lot of people are very excited to get the Aristotle test now. How are they going about doing that?
Yeah, so I thank you for giving us a platform. I really do want to reiterate the importance of understanding one's body at the molecular level to try to achieve optimal beauty results, as well as optimize their health in other domains. As we grow, we are offering within the next hopefully couple months a gut microbiome test as well, known as the ILIA. And we will expand to proteomics and transcriptomics and genomics. The goal of Theriome is to provide a deep molecular profile at every single level of systems biology, as well as to integrate that data to really tease apart your global biological functioning, which is more than the metabolism. It's more than the genome. Your functioning is very Gestalt principle. So the whole is greater than the sum of the parts.
Yeah.
Now, if listeners want to go ahead and start with the Aristotle test and discover their unique metabolic blueprint, which is, really key to looking at your global metabolic functioning and improving it, they can go to www.therio.me, and there they can learn more about our products, the science behind our products, contact us with any other information, as well as order their Aristotle test kit, which comes with, like I mentioned earlier, readouts on every single one of those 126 metabolites and the univariate implications of those levels, as well as reports on the 12 health domains, the personalized recommendations coming from our digital twinning platform, as well as a list of 344 blood disease signatures. We report the ones that are significantly matched to them. In addition to the test, included with the price of the test is a free consult with one member of our science and medicine team. It'll always be a very advanced researcher or physician. We have MDs and PhDs on our team who will sit with you for 30 minutes and go over any questions and optimize your recommended wellness routine to match your daily life, and really empower our customers to not just have the report, but have that interaction with a member of our science and wellness team. Again, somebody who's it's always one of our PhDs or one of our MDs who sit with you to discuss those results and empower you to implement those changes and experience a significant improvement in your sense of well-being.
Fantastic. I'm very excited. I'm going to keep everyone updated as far as my results and how it's going. Paniz, this was one of my most enjoyable podcasts I've ever had. So I thank you.
That?
Yes, 100%.
I hope you do. I was so scared I would come unprepared. I'm like, health and beauty.
Listen, I'll give you a few things. You are an interesting person. Let's put that aside. Okay, you speak very eloquently. That's number 2. Number 3, there are about 7% of people that are what we call early adopters or innovators, and unfortunately, I'm one of them. And
exactly what you mean.
it means that the minute you talk about the future in a compelling way, in a way that can apply to an individual, you've hooked the 7%. The rest, the rest, I'm not sure about them. I'm that we need to A/B test it. But as far as those 7%, you got them immediately. And I'm telling you that this is going to be a project that I believe will change. Obviously, will change the world. We can have another 3-hour discussion about different ways where the world of medicine can obviously improve by integrating metabolomics. But I mean, I know you're going to be successful, and I wish you all the luck. And you have an amazing team, so I really thank you for this podcast.
Thank you so much for having me, Amitay. I was really a privilege, and can't wait for our paths to cross in the future.
Amen. All right. Thank you, everyone. What an amazing, amazing episode. I'm super excited. Before we wrap up today's episode, I'd like to address some listener questions. First one is, I've been hearing about the benefits of metabolomics for skin health. Can you shed some light on this? We got it from a person that knew that we're doing this podcast. So certainly, metabolomics offers insights into the small molecules in our body, which can provide information on how our metabolic health is. When our metabolism is functioning optimally, it can manifest in clearer, more vibrant, younger looking skin and actually younger functioning skin. Obviously, we've covered this a lot in this episode, but we wanted to recognize the question. Another question is, what are the top 3 recommendations for someone just starting out on their biohacking journey? So begin with the basics. First and foremost, prioritize sleep and sleep hygiene. If you don't know what that means, Google it. Manage stress is another one, and obviously ensure a good anti-inflammatory diet. Once you have these foundational elements in place, you can explore more advanced biohacking strategies. But this is first and foremost. Third question is, how often should one get metabolomic testing done to optimize their skincare routine? So ideally, at least once a year, you should consider testing, or whenever there's a significant change in health or lifestyle. It can guide adjustments in skincare routines based on the body's current needs. And we're going to make sure we work with Theriome and Dr. Paniz Jasbi to give you some better insights in the future. That's part of why I'm so excited about this episode. Well, thank you to all who sent in their questions. If you'd like your query to be addressed in future episodes, simply leave a review on Apple Podcasts, and we'll make sure to cover it when it's appropriate. Once again, a huge thank you for joining us today. And remember, the journey to optimal health and beauty does not have an expiration date. You should do it all the time. Stay curious, stay informed, keep biohacking your beauty, and we'll see you here next time. Thank you very much.